Hey everyone, it's Sanjeev from KodeKloud, and today we are going to take a look at a tool that was created to address some of the challenges that we face when it comes to working with secrets in our Kubernetes cluster. Now, there's a variety of different tools that have been created around this one problem, which is managing secrets. There's tools like External Secrets Operator, Sealed Secrets, and today we're going to take a look at a tool called Secret Store CSI Driver. And so what we're going to do is we're going to go over, why was this tool ultimately created? We're going to go over how this tool differentiates itself from some of the other tools like External Secrets Operator and Sealed Secrets. And then we're going to do a demo going over how to actually use this within our Kubernetes cluster. And you're going to see that this is a fantastic tool that we can utilize to manage secrets within Kubernetes. So let's go ahead and dive right in and take a look at how to work with the Secret Store CSI Driver. Now, before we get started going over what is the Secret Store CSI Driver and how to use it, I want to go over why exactly the Secret Store CSI Driver was created. What problems does it help us address? Now, within Kubernetes, anytime we have any kind of sensitive information that our application may need to use, whether that's credentials to authenticate with like a cloud provider or talk to a database, we're going to store them in a Kubernetes secret. Now, the problem with this is if we take a look at DB password, it looks like that value is secure, but it's important to understand that this is actually not secure. This is base 64 encoded, which means that it can easily be decoded. So don't mistake encryption is secure. If you encrypt data, it's going to be secure, but if you just encode data, it can be easily. So this data at this point, the DB password, anybody that has access to the secret will be able to know the value of the DB password because they can easily decode it. And so if we ever upload our YAML manifest, our Kubernetes manifest to GitHub, which most likely we do or we want to do, then anybody that has access to that GitHub repo will automatically know our database password because they're able to decode that value. So that's one of the issues that we need to address because right now there's no way for us to define secrets and safely store it in GitHub because all of our secrets can be easily decoded. In addition to that, a lot of organizations have started making use of external secret stores. So things like HashiCorp Vault, AWS Secrets Manager, Google Secrets Manager, and Azure Key Vault. And so what these different services allow organizations to do is it allows them to manage all of their secrets in one central location. So all of their secrets will be stored inside one of those platforms, and then any applications that they need to have access to those secrets, they will just pull those secrets using an API. So that way they don't have to manage secrets across multiple different locations. They'll all be stored in one central location. And so with all of these secrets being stored within one of these external secret stores, we need a way for Kubernetes to be able to pull those secrets and store them and sync them within native Kubernetes secrets so that any application running within a Kubernetes cluster can actually make use of those secrets. And so natively, there isn't a way to do that, but that's why ultimately tools like the Secret Store CSI Driver, the External Secret Store Operator have been created so that we can actually sync secrets from a secret store into our Kubernetes cluster. All right, so we went over why we would need a tool like the Secret Store CSI Driver. Let's talk about what exactly is it. Well, the Secret Store CSI Driver synchronizes secrets from external APIs and mounts them into containers as volumes. So if you're using something like AWS Secrets Manager, it's going to pull those secrets from the AWS Secrets Manager or any other secret store that you're using, and it's going to mount them as volumes into your pod so that your application has access to those secrets. And so once again, one of the main benefits of this is that we get to use one of those central secret stores. So we get to manage all of our secrets in a central place like HashiCorp Vault or AWS Secrets Manager so that we don't have secrets kind of scattered all over the place. We have one place to manage all of our secrets, and then our Kubernetes clusters or any other platform or tool that we use can just pull those secrets dynamically. And most importantly, because it pulls these secrets at runtime, essentially, the great part is that we don't need to worry about checking secrets into Git because the secrets aren't going to be stored in Git because it's all pulled from the AWS Secrets Manager or whatever central secret store that you're using. Now, for those of you that know, there's several other tools that help us manage secrets within Kubernetes, things like External Secrets Operator and Sealed Secrets. And so I want to go over, what is the difference between the Secret Store CSI Driver and the External Secrets Operator and Sealed Secrets and what makes this solution a little bit different. It's not a major difference, but I do want to make sure that you guys understand, what it can bring to the table versus some of the other solutions. And there's really one main thing. The main advantage of using the Secret Store CSI Driver over some of these other solutions is that you no longer store credentials in Kubernetes Secret. And so usually if you use like External Secrets Operator or Sealed Secrets, what's going to happen is you're going to grab your secret from a central secret store and you're going to sync it with a Kubernetes secret. Well, with the Secret Store CSI Driver, you don't actually create a Kubernetes secret. So there's no secret within Kubernetes. It's just going to pull it dynamically from your central secret store, like AWS Secrets Manager. So what is the benefit of this? Like, what do we gain gain by not actually creating a native Kubernetes secret to manage our secret? Well, it minimizes the attack surface as much as possible because that's one less place we're storing our secret in. We're no longer storing our secret within Kubernetes. It's only in our secrets manager. And so because of that, this is great from a compliance and regulatory perspective because that's one less platform that has to adhere to various, regulatory bodies. And that's one less platform that we have to audit because now our secrets are only within Secrets Manager. We don't have to worry about storing them within Kubernetes. So how does the Secret Store CSI driver work? Well, we're going to have our Kubernetes cluster and we have to install the Secret Store CSI driver. And normally what we do is we're going to use something like Helm, a package manager, to deploy our Secret Store CSI driver. So we could just do a Helm install and that's going to install everything that we need. Now, what it's going to install? Well, first of all, there's going to be a couple of custom resource definitions and we'll go over what those are in a second. But let's say that we have our secrets stored in a central secret store. And in this example, let's say that we're using the AWS Secrets Manager. And let's say that we have our database credentials stored in there. So we created a secret within Secrets Manager called the db-creds, and we've got db_password as one key value pair and db_username as the other one. So what we need to do now is we have to basically tell the Secret Store CSI driver what secrets do we want synced and how do we actually access those secrets? Where are they stored? And so this is where we make use of one of the custom resource definitions that was created when we deployed that Helm chart, and that's going to be called Secret Provider Class. So this is an example configuration of a secret provider class. You can see we're using the AWS provider, and then we have to specify, where is our secret stored within AWS. So it's going to be stored in Secrets Manager, and here we're just giving it the name of the secret, which is going to be the name of the secret that we specified within AWS Secrets Manager. The next thing that we have to do is we have to create our pod spec and basically tell the pod that, hey, we want this specific secret mounted within the container within that pod spec. So here we'll create our pod spec and we're going to create a volume like we normally do. The only difference is we have to provide some properties for CSI, and you're going to see that we reference the name of the secret provider class, DB secrets. So those are going to match up. And that's basically just saying like, okay, whatever secrets that we pull from AWS, I want it mounted into this specific container. And you can see here, we mounted them in /temp within that specific container. So after we create our pod spec and then we actually deploy it to Kubernetes, what's going to happen is the kubelet is going to, ultimately be responsible for creating that pod, and it's going to see that we want a volume created. And so it's going to talk to the Secret Store CSI driver because it sees the configuration for that. The CSI driver will then see the configuration of that and see that it points to the secret provider. So if you remember, this is going to be the configuration for the secret provider. And so this is just basically telling, the CSI secret store, what credentials do I want and how do I access them? And so the secret provider is going to talk to AWS. It's going to get the value of the secrets that we specified. It's going to return it to the CSI driver. And at that point, we can then go ahead and create our pod, and the CSI driver is going to then mount the volume onto that pod. And that volume is going to contain the secrets that we pulled from AWS. And it's going to mount it specifically in the location that we specified. So in this case, we said we want to mount it in the /temp directory. And so it's going to mount all of those credentials as a file into that /temp directory. So let's go ahead and get started with a demo. Now for this demo, we're going to be utilizing AWS's Secrets Manager, and that's going to act as our secret store. So we're going to be focusing more specifically on that. Keep in mind that the steps are going to be a little bit different if you're using one of the other services like on Azure or GCP, but we're going to cover AWS. So the first thing that we're going to do is we're going to create our secret. So let's go ahead and search for the Secrets Manager service. And what I'm going to do is I'm going to create a new secret, and this is ultimately what we're going to mount into our pod. And here I'm going to just select other type of secret so we can provide key value pairs. And I'll just say maybe we're going to have a username property, and this is going to represent, this could ultimately represent anything, but I'm going to, in this example, use it as a, like database credentials. So I'll say username equals user123, and then password, I'll say this is password123. And I'll give this a name of MySQL-creds. So this is going to have all the credentials for connecting to a MySQL database. I'll hit next, and then we'll leave all the others as defaults, and then hit next. And finally, we will store that. And if I hit refresh, we should see MySQL-creds. And if we go here, we should be able to see all the key value pairs. We've got username, user123, password, password123. So now that we have our secret configured in Secrets Manager, let's go ahead and set up the Secret Store CSI driver for our Kubernetes cluster. And so if we take a look at the documentation page, and you can use this URL right here, and I'll make sure to include that URL in the description for this YouTube video, but we can go ahead and select installation, and this is going to walk us through the steps for setting this up. And it's going to be utilizing Helm to actually just deploy a Helm chart so that it can configure everything for us with just a simple command. And so there's two things that we have to do. And so first we have to install the Secret Store CSI Driver repo. And then from there we can install the CSI Secret Store CSI Driver chart that's listed right here. So I'm going to copy this first line. And I'm going to go to my terminal now, and we can just copy and paste that. And then we can go to the second line. And once again, if we just take a look at the command, we're going to create this chart right here. And what we're going to do is we're going to deploy it in a namespace of kubesystem. You don't have to use the kubesystem namespace. Just make sure you don't use the default namespace. Make sure you have a separate namespace for the CSI driver. We'll just go ahead and deploy it into the kubesystem namespace like the example does. All right, so now that our chart's installed, if you want to take a look at some of the things that it's deployed, we can go ahead and just do a kubectl get crd, and we'll do the namespace of kubesystem because that's where we deployed it. And you'll see the custom resource definitions that were created by that Helm chart. And so you can see here, we've got two of them that look interesting to us, which is the secret provider class from the secretstore.csi, and then we got secret provider class pod status. So it's just two CRDs, but that's what comes with the Helm charts that were installed. Now, if we go back to the documentation, you'll see that there's two kind of notable optional values. We've got sync as Kubernetes secret. That's one of them. And what that does is that it'll actually create a Kubernetes secret and keep it synced up with the secret that's in AWS. By default, that's set to be turned off. And then we have secret auto rotation. If you enable this feature, what it's going to do is anytime you make changes in the secret store, it's going to continuously pull the secret store to see if there's any changes and then update the secret within your pod accordingly. So by default, both of them are turned off. And we'll see later on in this video what it looks like when we turn on the secret auto rotation. We're not going to really worry too much about sync as Kubernetes secret. One of the benefits of utilizing the CSI Secret Store driver is that we don't need to have Kubernetes secrets. But if you did want to, for some reason or another, you can always turn that on. Now, the next thing that we have to do is set up the AWS integration with the Secret Store CSI driver. So there's specific instructions for AWS, and keep in mind that this is just because I'm using AWS. If you're using Azure or GCP or Vault, you're going to have your own specific steps for setting this up. This is just for AWS. Just keep that in mind. So let's take a look. And if you go to this GitHub page, once again, I'll have this link in the description as well. This is going to have all of the instructions for us. And so there's a couple of things that we got to do. So this is just the requirements, which is we have to have, in this case, since we're using AWS, we have to have an EKS cluster, and then we have to have the Secret Store CSI driver installed, which we already do. And then we have to, the first step would be to install the AWS provider. So I could just copy this command. It's going to give us a manifest for deploying that. So I'll copy that. Now, the way that the AWS provider works in the Secret Store CSI driver is that what it allows us to do is actually bind in a policy to a Kubernetes service account. And that's specifically with EKS clusters. And so this is once again how the AWS provider works. The other providers for Azure and GCP, they're going to be completely different. They handle the whole authentication with their platform completely differently. So keep in mind, some of the steps that I'm going over right now are just specific to AWS because that's what I'm going to do in this example. So we're going to first create our policy. So I'm going to go back to AWS and I'm going to search for IAM. So here we'll then go and select policies and we're going to create a policy. So I'll create a policy here and I'm going to, we can use either JSON or the visual editor. So first we'll choose services. So remember, this policy has to give Kubernetes permission to retrieve the secrets within the Secrets Manager. So I'm going to search for Secrets Manager. And then we have to specify the different policies or the things that it can do within Secrets Manager. So let's open this up, and we don't really need either of these, but if I go to read, this is going to be where we need it. So we need to be able to describe secret, and we need to be able to get secret value. So those are the only two permissions. And then here we have to specify the specific resources. So I can say add RN, and then you could specify the exact resource if I want to. I could say US East -1. That's where I created that secret. And then the secret name, which I think was like MySQL creds maybe. And so you would just hone in on the specific ARN of the secret that you created. Or if you want to, you could just do any region, any secret. Once again, that's not the safe way to do things. You always want to make sure you give only the permissions it needs. So if you only wanted to give it access to those secrets, then you would want to specify that. Or if you wanted to give access to all of the secrets, then you can just do what I'm doing here. And so I'm just going to keep this example simple. So I'm just going to give it full access to all the secrets. But like I said, you want to make sure that you drill down and only give it permissions to access the secrets that it needs to know about. And then we can go ahead and select next. We'll give this policy name. We'll call it, how about CSI EKS Access Secrets Manager. And then I'll create that policy. And we shall have successfully created our policy now. Now, if we go back to the AWS instructions, you'll see that there's a couple things that we have to do, which is now we have to create the IAM service account. So this is going to basically bind that IAM policy to a service account that exists on our Kubernetes cluster. So it'll create the service account and then assign the necessary permissions. That way our pods can then retrieve the secrets from AWS. So there's this command that we can use using the EKSCTL utility. So if you aren't familiar with AWS or EKS, it's just a CLI utility that makes it easy to work with EKS clusters. Once again, this is only specifically for anyone that's using the AWS provider in the Secret Store CSI Driver. If you're using Azure or GCP, it's going to be a little bit different. So I'm going to open up the terminal again, and we're going to enter in a pretty long command. So the command is going to look like this. We'll say EKSCTL, create IAM service account. Then we have to give the service account a name. So what this is going to do is it's going to create a service account in our Kubernetes cluster, and we have to give it the name that we want. So I'll call this, since in this demo, I'm going to, assign these secrets to a API container. I'll call this API-SA for service account. Then we have to specify the region that my EKS cluster is in. So I'll say US-East-1. And then we have to provide the EKS cluster name, which happens to be EKS demo 1. And then we say --attach-policy -ARN, and then we have to get the ARN of the IAM policy that we created in the previous step. So I'll go back to AWS and I'll search for, I forget what I called it. I believe it was this one right here, CSI Secrets Volume Secrets Manager. I'll click on that. We can get the ARN right here. And then I can just paste that in. Then just a couple of other flags, which is --approve and a flag of --override -existing service accounts. And that should be all that we need. So I'll hit enter and we'll let that run. And so this is going to actually create a couple things. It's going to create a few things within AWS as well as the service account in our Kubernetes cluster. All right, so now that's complete. If I do a kubectl get service account, we should see that it created a service account based off of the name that I gave it, which is, if we take a look at the -- name flag, API-SA. And if you want to just poke around and we can take a look at what that's going to look like. If I do this, we can do a describe. And you can see several details like image pull secrets, mountable secrets, annotations, and a few other things. Now, the next step is to tell the Secret Store, the CSI Secret Store driver, how to actually, talk to AWS. And the way that we do that is if I type in kubectl get CRD, there's going to be a custom resource definition for this. And so that's going to be the secret provider class. So let's go ahead and create that. So I'm going to create a new file, and I'm just going to call this secret provider.yaml. And I'm going to provide some base configuration, which is here we use the API version this, which is just in the documentation. And then the kind is going to be that custom resource definition. Then we'll give it metadata. So what is the name? This is going to be any name that you want. I'm going to call this database-AWS-secrets. And then we'll go under spec. Here we'll say that this is a provider for AWS. And then we have to pass in some parameters. We'll say objects. And then here we have to provide two values, which is going to be object name, which is going to be the name of the secret that we stored within AWS. And so that's just going to be mysql-creds. And then we have to provide object type, which is just going to be Secrets Manager. And so this MySQL creds, that's going to come from AWS. So if I go back to here, we can see MySQL-creds. And so now we can do a kubectl apply, and we can apply that secret provider. And I realized I forgot to save that file, so let's run that again. Now if I do kubectl get secret provider class, we should see it show up here. All right, so I think we've got everything set up now. The last thing that we have to do is let's just deploy a pod and make sure it gets access to the secrets. So I'm going to create a new file, and I'll just say this represents my API deployment. And I'm going to paste in just some basic configuration for deploying a pod. So if we take a look at this, I've got a deployment. Here we just called it my app, and it's going to deploy an Nginx container. I understand that's not technically an API, but this is just meant to be a simple demo. And so we want to give this container, this pod, access to the secrets within AWS. How do we do that? Well, there's going to be a couple things that we have to configure. The first thing is we have to configure a volume. So this is going to be just like any other volume that we configure within a pod. So we'll go under spec, we'll say volumes, and here, I'll give it a name. We'll call this, how about db-creds? And then we'll say CSI. Then we'll say the driver that we're going to use, which is going to be following right here. And once again, this is just going to come from the documentation. We're going to set read only to be true. And then a few other things, which is volume attributes. And then we'll say secret provider class. And this is going to reference the provider class that we created here. So we can just copy this name and pass it here. All right, so we've got our volume, and obviously once we define our volume, we have to then mount our volume in our container. So we'll go under an Nginx container. I'll say a volume mounts. What's the name of the volume? That's the db-creds. And then we'll say mount path, and then specify wherever you want to mount it. I'm just going to mount it in /temp because this is just a demo. All right, and so that's going to be pretty much it, but there's one last thing that we have to do. If you recall, let me see if I can find the output of that. Remember when we created the service account? So this service account is what it's going to be used to authenticate with AWS to actually retrieve those secrets. So we're going to actually have to specify the service account. We want to make sure our pod uses that service account. So that service account is called API-SA. And so here we'll just go and just like we would any other time, whenever we want to use a specific service account, we'll say service account name, and this is going to be what we just copied, API-SA. So now that we got that, let's go ahead and apply this. All right, so it's created. Now let's go ahead and do a kubectl get pods, and let's see if it was successfully deployed. All right, we could see it's in a container creating state. All right, so if I do a kubectl get pod, let's take a look at the status of the pod. We can see it's still in container creating. Something's probably wrong. It's been up for 78 seconds. So if I do a kubectl describe pod, it's going to usually give us some pretty good detailed error messages. And here we could see mount volume failed for db-creds, and then it says, failed to mount. And then here it says must use object type when a full ARN is not specified. So there's something with the object type configuration in our secret provider. So if we go here, I know because based off the documentation, I made a typo. So this should not be a separate entry. This should just fall under there. So that's probably what's causing that issue. Let's go ahead and apply that. And then I'm going to do a kubectl get pod. We'll go ahead and just delete that just in case. Start from scratch. Now if I do a kubectl get pod, all right, now we can see we redeployed the pod, and after that correction, we can now see it's in a running state. But even though it's running, let's make sure that it actually was able to retrieve our secrets. So I'll do kubectl exec. We're going to exec into it, and we'll just drop into bash. And I'm going to cat etc, and under etc, oops, not etc, we want to go into /temp, and I'll just cd into there for you guys. If we take a look, there should be a file called mysql creds, which is the name of the secret. And if I cat that, we should see we've got a JSON object with the username and password stored in there. So this shows that we were successfully able to retrieve our secrets from AWS and mount it as a volume into our pod that's running in our Kubernetes cluster. All right, so now let's say that we had to change our database password. So we go to our secrets stored in our secrets manager, and under MySQL creds, let's say that I want to edit one of these properties. So let's say the password is now going to be new secret password. I'll save that. And what we'll do is we'll go and I'm going to run that same command. What do you guys think is going to happen? If I run this command, we can see our password is still password123. So it doesn't automatically update for us. Obviously, we can delete the container if we wanted to, or delete the pod. And then once a new pod gets deployed, it's going to retrieve the new value. But instead of that, if you wanted to dynamically update on your behalf, if you recall at the beginning of this demo, I went over the documentation and it pointed out some optional values, which is the secret auto rotation. What this is going to do is basically continuously ping AWS. And if it sees that there's a change in one of your secrets, it's going to update that and make sure that the updated values are mounted in your Kubernetes cluster or in the pods running in your Kubernetes cluster. So let's go ahead and do that. What I'm going to do is I'm going to run a few commands so that we can actually get the values file for that Helm chart. So I'll say Helm search, I believe repo, and I'll just search for CSI. I forget the name of the chart. Okay, so this is the name of the chart that we used. And what I'm going to do is I'm going to do Helm show values. We'll paste that in. And this is going to print out all of the different values that we could set. And what I'm going to do is I'm going to save that to a file. We'll call it values.yaml. And here you can see all of the different values that we can set. Now, we don't care about most of these. We just care about that one specific property. And so let me see if I can find that. And this is the one that we want, enable secret rotation. So I'll set this to be true. And then you can also set a rotation poll interval. So this is basically just how often should it poll AWS to see if there was a change in your credentials. The default, I believe, is 120 seconds, so every 2 minutes. We're going to leave it as default, but if you did want to customize it, just go ahead and set that property to be how many seconds you want that interval to be. So let's go ahead and upgrade our Helm release with the new configuration changes that we made to that values.yaml file. So if I do helm list-n cube-system, the name, we called it CSI Secret Store, so I'll say Helm upgrade. Then we grab the name of that release. Then we grab the name of the chart, which is going to be that long name that I copied previously. And then here we can pass in the --values flag so that we can pass in our values.yaml. And then remember, this is going to be in the namespace cube-system. All right, so we've successfully deployed those changes. And so now if I go back to that container and I just hit the up command and we cat that file, we could see that it now has the new secret password. So every 2 minutes or whatever the default value is, it's going to pull and ask AWS, has the secrets changed? If it has, it's going to update those values kind of dynamically on the fly to your container. And, obviously with that in mind, if you're going to do it like this, then you're going to have to make sure your application has the logic built in to actually, make sure and check that the values in this file haven't changed. Because if it has changed, then it has to actually, go ahead and pull those new values in and update the application accordingly. Video on Kubernetes Secret Store CSI Driver. So we got a chance to take a look at how we can actually utilize the tool to manage secrets within Kubernetes and manage secrets within our application. And we got a chance to dive into how it kind of differentiates itself from some of the other tools that are available within the Kubernetes ecosystem. I'm curious to find out what is your favorite secrets management tool, especially when it comes to Kubernetes, whether it's external secrets operator, sealed secrets, or CSI Driver. Please let me know, post a comment in the video and let me know which one is your favorite, and I'll see you guys in the next one.